Hello and welcome to Honors Function. In this video, I'm going to do some graph shifting of secant, cosecant, tangent, and cotangent. Okay, and hopefully you will see it's very simple to do. We have looked at these four graphs in the previous video, so let's begin graph shifting them. All right, first example. Okay, so how do you graph this function right here? I could find the range, I could find the domain, I could do it all analytically. I know this cannot be equal to k pi, and my range, I think I did it in the previous video, this range. But this is not how it's done. It's much easier than that. It's much faster. This function right here is actually, you could write it like that, right? It's -3, 1 over, and here you have the sine of pi x plus pi over 3, right here, minus 2, right? Okay, so that's how we looked at cosecant of x as 1 over sine x. And we know when this is 0, there will be a vertical asymptote. That's a problem, right? So you're going to have a vertical asymptote. And from the graph of this, we know how to graph the cosecant, right? The maxes and means are the same, and then you play with the behavior around the asymptote. So the whole idea right here is to simply graph this function right here. If I give you this function, what you want to do is graph this one right here, -3 sine of pi x plus pi over 3 minus 2. Okay, let's graph this one, and then from there we'll quickly do this one, and then at the end, of course, we can erase that. Okay, we can erase that. Okay, so let's decide on our y scale. So for the y scale, I'm looking at this and this, and the y scale, that's easy, that 1. Okay, so 1 unit equals 1 mark, 1 tick mark, right? Okay, let's decide upon the x scale now. That's you have to be careful for this one. That's the most important one. So what's a period? 2 pi divided by pi, and so it is 2. Therefore, 1/4 of the period is 1/2. Okay, so it's going to be an important number. I will have to count in 1/2 to jump. Let's get the phase shift. Pi x plus pi over 3 equals 0, which means that x is equal to -1/3, right? X equals -1/3. Okay, so what's going on right here? I need to be able to count in 1/2, and I need to be able to plot -1/3. That's my phase shift. So 1 tick mark, 1 mark equals 1/6 of a unit, right? So it will take 6 marks to get to 1 unit, right? 6 marks to get to 1 unit. Okay, all right, let's see what's going on here. So 6 marks to 1 unit on my x-axis. So here we go. 1, 2, 3, 4, 5, 6. That's 1. 1, 2, 3, 4, 5, 6. That's 2. 1, 2, 3, 4, 5, 6. And that's 3. 1, 2, 3, 4, 5, 6. -1. 1, 2, 3, 4, 5, 6. -2. And do I have another? 1, 2, 3, 4, 5. Oh, right there. -3. All right, and I said 1 tick mark on the y scale. So 1, 2, 3, 4, 5. I don't want to put 1 everywhere. 1, 2, 3, 4, 5. Here we go. That's plenty. I understand perfectly what's going on. Okay, so that was easy. Let's now draw my horizontal line. There are 3 horizontal lines. So the middle line is at -2, and then the amplitude is 3. So my horizontal line at -2 right there, that's the middle line. -2 right here. And then 3 up and 3 down. Three up, 3 down. Okay, we are ready now to graph our sine function, right? It's a negative sign, right? So it's middle, mean, middle, max, middle. And you start at -1/3. Okay, so where's -1/3? it's right here. This is where I start, right here. I gotta go on the middle line. I start there, right there. And I count 1/2. 1/2, that's 3 tick mark, right? Okay, so 1, 2, 3, jump. Right? 1/2 is 3 tick mark. 6 mark is 1. 1, 2, 3, jump. 1, 2, 3, jump. 1, 2, 3, jump. 1, 2, 3. 1, 2, 3. All right. Other direction. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. All right. 1, 2, 3. Okay. Okay. Now, you really don't have to draw the graph. I mean, this curve right there, they don't have to be drawn because I have the point that I am interested in right now. Let me tell you what I mean. Okay. So, what's going on when the sine hits the middle line? It's like sine equal to 0, right, on the middle line. I mean, before you do the graph shift up or down, which is about the y, right? In the inside, you have 0. The sine is 0. After that you move up or down, that's not the problem. I'm sorry, I'm speaking. Look what I mean right here. This is a moving down. When this is 0, right here, when this is 0, before you move down, that's an issue. That cannot be 0, okay? So you're going to have a vertical asymptote anytime the sine graph hits the middle line. Right here, vertical asymptote, right there. Here we go. That's the middle. See, I don't need the graph, I just need the point right here. Let me draw the other side of these lines. Here we go. All right, here we go. Here's your vertical asymptote. And then what? And then you remember this, when sine is equal to 1, cosecant is equal to 1. When sine is equal to -1, cosecant is equal to -1. Now, this is not 1 and -1 because I moved down 2 units, but it's going to be the same, whatever the number is. It is, well, actually, this is 1 and this is -5, it looks like, okay? So this value will be taken by our cosecant graph. And then what? And then it goes like this. Like that. Oops. Like this. That's it. Here's the graph you wanted to draw all along. This one right here. Okay, so it's very simple. You draw the corresponding sine or cosine graph for a secant, and then you draw your vertical asymptotes, and then you draw the branches of the sine or cosine cosecant graph that you are looking for. Okay, secant or cosecant, I'm sorry, secant or cosecant. Okay, let's do a 10. Actually, before that, I think I have named the graph question. Yep, you see right here? That's a name the graph question right there. Okay, all right, so here's max, or rather local mean for this one, and here's the local max for this one. This is -6 and this is 0, so -3 is going to be my middle line. All right, so don't forget what I'm looking for. I'm looking for y equals, so a trig, and trig in this case is going to be either secant or cosecant. Bx minus c plus d. And a is plus or minus, okay? We'll see. Well, we have the d right now. We have the d, right? d equals -3. That's easy. And a equals, well, a equals right here or right there. That's 3. Okay, that was also easy. Let's get b and c. Now you remember, c will give us the name of the trig, either a plus sign, a minus sign, a plus cos or minus cos, okay? So actually, I erased this, but I need them. Let me get this point back right here. Okay, so let me measure a period. Here we go. From here to here, that's a full period, right? So what is it? How many tick mark? 1, 2, 3, 4, 5, 6, 7, 8 tick mark. Okay, so a period is 8 times, what's the length of a tick mark? 1/2. All right, so a period is 4. A period is 4. Now you remember that t equals 2 pi over b, so this is the same as b equals 2 pi over t, right? Therefore, b is pi over 2. 2 pi over 4, that's pi over 2. We got b, pi over 2. Okay, so now let's get c. And for c, you have a choice, okay? So let me get my middle point right here. Where am I? I said 4, so 1, 2, 3, 4. That should be the middle right here. 2. Sorry, what's going on? 1, 2. Yeah, right here, right there, sorry. Like that, like that, like that, and like that. Here we go. This, or this. Okay, so you choose, guys. Okay, if you choose this point, it's going to be a negative secant. If you choose this one, it's going to be a plus sign. Okay, there it would be a plus sign. Sorry, I guess I should say plus cosecant, because after all, we do want the reciprocal graph, right? So plus cosecant. Here it would be a negative secant. Here it would be a negative cosecant. And my plus secant, I can take it here or there. I guess this is closer. Secant right here. Plus secant. That's it. So, and then you get your phase shift, okay? That's gonna, so let's take this one. Let's take this one is close to the y-axis. So my phase shift is 1/2. So my phase shift is 1/2. So let's find c, okay? So bx minus c equal to 0, and x is 1/2. b is pi over 2. So pi over 2 times 1/2 minus c equal to 0. So c is equal to pi over 4. And if I take this as my phase shift, what's the name of the graph? It is y equals, so we said it's a negative secant, right? So negative c, I think it was 3, 3 secant of b is pi over 2 x plus, minus, you put a minus in this formula, minus pi over 4, and then minus 3. And of course, you can check it with your calculator, okay? Just put the window that I gave you in the graph right here, but you can check it out with your calculator. Okay, let's give it one more name and we'll stop, okay? I'll use this one right here. I'll use a plus secant, okay? So my phase shift now, actually, you know what? I want to use a negative one. I'll use a minus cosecant. My phase shift now is negative 1/2, okay? So with my phase shift equals to negative 1/2, I have pi over 2 times negative 1/2 minus c equal to 0, which means that c is equal to negative pi over 4. And there, what's the name of it? It's a negative cosecant. So now we have y equals negative 3 cosecant, right? Negative cosecant of pi over 2 x, so minus c, and c is negative, so plus pi over 4 minus 3. You see? Very simple, guys. Okay, let's do a 10 graph and let's call it a day. Okay, so the y-scale, I'm still going to be looking at this number. I don't need to look at this one. Yes, I do actually. I do need to look at this one. You will see why, because this is where 10, this is when the regular 10 goes through pi over 4, 1, or negative pi over 4, negative 1, and that's going to show the stretch of 10, okay? You'll see how it works. So the y-scale, 1 mark equals 1 unit, right? 1 unit. So how do we decide on the x-scale for 10? Well, in a way that is very similar to the way we decided on the x-scale for sine or cosine, okay? We take a period and we divide it in 4. So let's check it out. Let's check out the period of 10. Now be careful, the period of 10 is not 2 pi, the regular period is pi, okay? So pi divided by b, so pi divided by pi. Well, that's just 1. Therefore, t over 4 is equal to 1. let's look at the position. Sorry, I meant 1/4 right here. Let's look at the position of the vertical asymptotes. The vertical asymptotes happen when pi x plus pi over 2 is equal to pi over 2 plus k pi, right? For tan and secant is pi over 2 plus k pi. So these two cancel, and then you divide by pi, so you have x equals k with k in z. Okay, so if I choose 1/4 for my scale, I'll be able to represent all my vertical asymptotes very nicely. So let's do that. All right, so 1/4. So 1 is going to be right here. That's 1. 1, 2, 3, 4. That's 2. 1, 2, 3, 4. Right here. 1, 2, 3, 4. Okay, and I do have a vertical asymptote every integer. So here's a vertical asymptote right here. Here's another one right there. The y-axis is a vertical asymptote. Here we go. Okay, so now what do we do? Okay, what do I want to... Where's my middle line now? We shouldn't say middle. There's really no middle, right? But my middle line is at plus 3. So 1, 2, 3. Here we go. Okay, now, guys. 10 hits the middle line in the middle of a period, right? So it's going to go right here in the middle of a period. I will be hitting my middle line, okay? The regular 10 goes like this, right? The regular 10 goes like this. But first of all, this is a negative 10. This is a negative 10, so it will be flipped. And now what do you do with this 3? The regular 10, if you go 1/4 of a period to the right here, you go up by 1 unit. And if you go 1/4 to the left, you go down by 1 unit. You know, this is a pi over 4 thingy, right? Pi over 4 thingy. But this time, 10, first of all, is switch. And then this 1 unit up or down gets multiplied by 3, right? So if I go 1 to the right, 1, 2, 3 down, 1 to the left, 1, 2, 3 up. That's it. This is how I will do my 10 graph. The 3 right here is the coefficient of dilation for 10. Here we go. Here we go. And it goes down because the graph was flipped. There is a negative sign in front. All right. Like that. Of course, you have some asymptotes here. You have to be careful. Here we go. So, as you can see, this 10, it could be written as a co-10, right? It's got the shape of a co-10, a plus co-10, right? Okay, let's do a find the name and let's call it a day. I think I said that for the other example, did I not? Okay, all right, let's find the name of this graph right here. So here's a vertical asymptote, here's a vertical asymptote right there, and here's another one right here. Where's my middle line? Right here. Here's my middle line, right? In the it hits the center between two asymptotes right here. Okay, so what is this? This is -3. So d equals -3. All right, I got that. Now I can call that a tangent. Why not calling a tangent? I got my coefficient right here. That's, see, it's 2 up and 2 down, right? 2 up and 2 down. So a equals 2. A equals 2. Right here, we're looking at y equals plus or minus a trig of bx minus c plus d. Okay. All right. Let's get a period. A period is this right here. So 4 tick mark and 1 tick mark is pi over 2, right? So t equals 4 tick mark and 1 tick mark is pi over 2. Yep. So 4 times pi over 2 is 2 pi. Okay, that's a period equal to 2 pi. So what is b? We know that t equals pi over b, right? Therefore, b equals pi over t. And so it is equal to pi over 2 pi, which is 1/2. 1/2 right there. Okay? And I want to call this graph a 10 graph. So I'm going to be looking, let's look at this one right here. Normally I haven't talked about phase shift. My phase shift for 10 is 0, but here my phase shift is negative pi over 2, right? So it's exactly the same work that we did for all the other functions. So bx minus c equal to 0 will find your phase shift, okay? So b is it 1/2? Yeah, so b is 1/2. So 1/2 times, I will take for my phase shift negative pi over 2, negative pi over 2, minus c equals 0. And so we have c equals to negative pi over 4. That's it. I got the name. Y equals, so it's a plus 10. It's 2 times 10 of x over 2 minus pi over 4. And then, was it minus 2 or minus 3? Minus 3. Minus 3. Here we go. I found the name of this graph. Okay, hey, I'm sorry, these two last videos were a little bit on the long side. There was a lot to cover. I hope it's clear enough. The really important one were sine and cosine, secant and cosecant, no secrets. Tan and cotan. If you have some question, if things are not clear, I'll answer them when I get back, but you will see it's not that challenging. Thank you for watching.